Welcome to Procurement Block, a podcast all about digital transformation in procurement and supply chain, and how blockchain, risk management, and change management all factor in. I'm your host, April Harrison, Marketing Director for Trust Your Supplier. I'm a procurement novice, eager to learn more from the people who are at the forefront of procurement innovation. On today's episode, I am being schooled by Mohan Venkataraman. For more than 3 decades, Mohan has served in information technology roles, including work with 8 employers, over 120 clients, 60-plus applications, and hardware that includes mainframes, mid-range, desktops, and process control systems. Mohan started the consulting and advisory practice with Chainyard CEO back in 2013 and supported the expansion into blockchain in 2016. He has been directly involved with over 25 blockchain solutions and enterprise and public blockchain platforms. Mohan has a strong interest in biotech and has been active with many local area biotech thought leaders in North Carolina. Mohan's interest includes mentoring young professionals and leaders while working with the community to leverage technology and improve lives. Join us as Mohan and I discuss the basics of blockchain, learn about the underlying principles behind blockchain, its relationship to Bitcoin, why blockchain is a team sport, and how it relates to shoeboxes. Hi, Mohan. Welcome to the podcast.
Thank you, April. I'm pretty glad to be here today, talking to you all.
I've read a lot of your bio. You're a really fascinating person. And can you just tell me a little bit more about yourself?
I've been in this industry for close to 35 years, and I've done technology across mainframes to mid-ranges, across many different languages, platforms, applications, domains, and industries. So that really enriched me in terms of how do I approach clients. And initial days, I was actually a field engineer. I did everything. I was sent to the field, so I did hardware installation, I did software installation, writing device drivers, writing applications. Everything was on the shoulders of the field engineer. I've been very fortunate to work with big companies that have really influenced and shaped my career, like DCM Data Products in India, Nortel Networks, Momentum Software, Texas Instruments, and Deloitte. So that's kind of what I am, in the sense I do enjoy talking to people, more a people person. I do like to travel, and I do like to learn all the time.
I've known you for a while now, and you're really, really brilliant. And I would think that would already be your superpower. Just the fact that you can be the chief technology officer, to me, seems like a superpower. But if you had another superpower, what would that be?
There is a philosophy in Sanskrit. It's called Vasudeva Kudumbakam, which it's a Sanskrit phrase that you'll find in all texts. All it means is that the world is one. So if I really had a superpower, I've often thought about this, is that why don't you just change the physics of this universe? Like we have gravity and all these things, change the complete physics and let everything start from scratch again, and where humans and animals and nature can all live together. So that's kind of, I have often thought about this. So that's what I would do with my superpower.
So Mohan, I am a novice in all things related to digital transformation, honestly. So I need you to school me a bit on blockchain. For me, my first association with blockchain was Bitcoin. First of all, what is blockchain? And then what is that relationship between Bitcoin and blockchain?
So let me start with Bitcoin, because everybody is familiar with Bitcoin, right? And
yes.
So you're all familiar with payment systems like Venmo and PayPal. We often use we wire money, or we use credit cards to pay. And so it's we use standard fiat currency. Fiat currency is traditionally like the US dollar or the Indian rupee or whatever, yes. Right? So we use that. Now, one of the goals of now Bitcoin is actually a digital form of currency. It's actually digital money, and it can be used for transactions on the internet using a peer-to-peer protocol. Peer-to-peer protocol is like groups of computers that can gossip with each other and then facilitate transactions. So really, Bitcoin was started as a cryptocurrency or a digital currency. It's got all the characteristics of a fiat currency. It's got numbers, it's got a transaction ID, and it is a medium of exchange. That means you can use it for buying goods and services. So it's got all those characteristics, but there are some fundamental differences. So when Satoshi Nakamoto back in 2008, now Satoshi Nakamoto, nobody knows who he is. It could be a group of people or it is some person who wants to remain anonymous. He felt that the traditional ways by which we transact, money is traditionally issued by a centralized authority like the federal government, the Department of Treasury. They issue money and they control its supply and its monetary purchasing power. So they can increase its supply and devalue the currency, or they can take away money and improve its value. And they also control the purchasing power, as well as they control how it can be used. Meaning, like you have all these rules and regulations on where money can flow, whether it's cross-border or whether it is buying certain goods and services, anti-money laundering laws, and these are all part of the characteristics of a centralized currency. Now, Satoshi felt that money should be free and we should be able to transact universally without any central authority controlling us. So the whole idea of Bitcoin is it's a decentralized payment system that was invented primarily so that money is generated by the network based on certain transactions and the volume of transactions and other characteristics. That money can freely be used for exchange of goods and services for any kind of transaction. And again, it is the network that really controls the supply and demand and its buying power rather than any central authority. So your question about like what is Bitcoin and what is blockchain? So the Bitcoin is digital currency and the underlying peer-to-peer technology that helps you to transact over the net is the blockchain. In this process, Bitcoin is the first network. It's called a public network because anybody like you, me, Karthik, we could go and join the network and we could be a member of the network and work with it. So Bitcoin is a good example of a public network. There was another group, it's called, who founded the Ethereum Foundation. Vitalik Buterin is one of the founders. He felt that Bitcoin is a little bit constrained because you're only doing payments. And he felt that there could be a better system that allowed you to want to build different kinds of applications. So when they built Ethereum, they came up with a couple of different innovations. One is on the network, you can put some business rules, package them, and they can execute on the network, and they called it smart contracts. So smart contracts are nothing but programs that run on the blockchain network and execute business rules before the transaction is processed. It's not just sending money from one point A to point B. If there are rules that need to be executed before that transaction can go through. And they also came up with many different innovations. Notable among them is tokens, the tokenization of assets. So they came up with the token economy, and they also came up with another good innovation nowadays is DeFi, decentralized finance. We're all used to centralized finance, but decentralized finance is what is catching on nowadays, where everything in the financial system is trying to move towards this concept. So that's another good example of a public blockchain. So both of them, you and I could be members, except that on the Ethereum network, we would buy Ether. On the Bitcoin network, we would buy Bitcoins. So let's take a very simple example, right? So I've worked in many industries where certain, which come under regulations, right? So for example, let us take Acme as a company, and they manufacture aircraft, and they have, let us say, suppliers who supply a very critical component that is regulated by the federal government or the European regulator, because these parts can be misused by if it went to rogue countries. So they want to track each and every part that has been manufactured, delivered, shipped, where they are. So Acme does not trust its own accounting firm. And so what it does is it hires 4 other outside firms. So that way the Acme wants to be sure that whatever it does not get penalized by the government for any of their transactions that is not appropriate. Acme's internal accountant goes and explains to all those four publicly hired accounting firms, this is how you have to process a transaction. When you receive a purchase order, you got to verify that the purchase order is from a legitimate organization. So he teaches all the business rules to these four outside accountants. And so those would be the business rules that they have to know, and they all have a common ledger. You know, the item master, right? Or the inventory ledger. Yep. So they are supposed to record every transaction on that. So every transaction that comes into Acme, let us say they have a purchase order for an aircraft, or they send a purchase order to their supplier for this critical part. What Acme does is it makes 5 copies of it, 1 for itself, and 4 go to these outside accountants, and they all look at it, and validate the transaction and keep it aside there. Now it keeps on happening. Transaction 1, transaction 2, transaction 3, copies are made, and it goes to all these 4 different outside parties, and they all, validate the transaction and keep it aside. Now, periodically, what can happen is, traditionally you have seen, right? We put things in shoeboxes. So similarly, like a bunch of transactions have accumulated at each location, and so one of the guys around in this, out of the 4 parties or 5 parties, says, hey, we need to box these things because it's becoming a big pile. So one of them says, shall we pile them up? And so all of them get together and say, hey, what's the balance currently? What balance do you have? What do you have? Accountant 1, 2, 3, 4. So they all compare their answers and they say the balance is X. If a majority of them say the balance is X, that means they've all processed the transactions correctly. At that point in time, the one who raised his hand and said, shall we box them? Will say, let's box them, and then let's start with the next set of transactions. So at that point in time, you take all the transactions in chronological sequence, put it inside the shoebox, and put some additional information inside, seal it, and say so many transactions are there in this box. It was from this date to this date, and then you put it aside. So you have boxed it. And then you repeat this process. So you got box 1, box 2, box 3, all in sequence. So that's kind of like a typical process, so that there is trust. So you know that exactly all of them have boxes, right? So if there is any problem, you can verify that 5 different parties have verified it and everything is accurate. That's what happens in a blockchain network, typically. So I would say in this case, the whole action of 5 different parties validating it are validators, and then executing the rules that the accountant taught at each location is kind of like a smart contract, and then putting it into the box, those transactions, after all of them have agreed on the answer. So if all of them have talked with each other, that is the consensus process, meaning agreement, and then they put it inside a box, and that box is a block. So that's kind of like a way by which blockchains operate, right? Except in the case of a blockchain, there's a computer on which there is this blockchain software that knows how to do all these things, gossip, send the transaction to 5 other computers, and then it knows how to periodically trigger a consensus process. And then how do you take all the transactions and cryptographically seal them into a file and then set it aside in a database. So this is kind of how an automated blockchain process works, similar to the analogy that I just gave you. Did I make any sense?
Yes. So I've got it. So that shoebox is the blocks, and then when you string those together, that's the chain.
Correct.
So that's the blockchain. Okay, and it's like a good system of checks and balances, and then a secure filing system as well.
Absolutely. So now, so things that I didn't mention to not complicate the conversation is, blockchain it came about because of trust, because no one party trusts the other party, right? If you really see in a business, I get a purchase order. Suppose there is a purchase order from we issue to a supplier, then the purchase order is interpreted by Acme in one way, and then it updates its systems like the SAP system or whatever purchase order system they use. The same copy goes to the supplier, and the supplier interprets it and puts it in a different way. And so when the actual shipments happen, then the two parties have to verify and check everything because they don't trust each other, and things could have gone wrong in between. And therefore, the whole system of there is a trust issue, which is what blockchain tries to solve. And then there is also potential for fraud or even manipulation of data or tampering of data, which is what blockchain tries to solve, which means that once you write inside that database, you cannot change it. Now, that's a good topic for conversation, actually.
Is that the main way that a blockchain database is different from the traditional one, is not being able to tamper the information?
Tampering is possible anywhere. Okay, so anybody who is a good hacker can hack it. Now, why does it not happen in a blockchain? So first of all, let's understand tampering, and then I'll tell you about blockchain databases. So when I have 5 accountants, right, and if I want to tamper, I have to go to all those 5 accountants that Acme has and go and change the transaction in each one of their shoeboxes, which which is very difficult in the real world. If there was only one shoebox, okay, it's easy. Open his box, make the change in the transaction. Instead of shipping 2, I say ship 1, and then I steal 1, right? So it's very easy. But when that same transaction has to be fixed in 5 boxes, it makes it very difficult in different locations. So if you imagine the Ethereum public network, there are more than 14,000 computers that that have the Ethereum software running, and they have a copy of the ledger. For a hacker to go and change a transaction in any of the ledgers, they have to change at least more than 50% of all the ledgers that are operating on that in the network, which is theoretically very, very difficult to do, because by the time another one is tampered, the network discovers that this has been tampered and it brings it back in sync, or there are new transactions that have happened. So that's what brings immutability to it. So immutability is not because the database is so essentially strong. If somebody wanted to tamper with it, they can start from the last box all the way to the box in which they want to do the tampering and rewrite all the transactions. But in a large network, it is virtually impossible to go and manipulate every transaction and bring them in order. The second reason is that all of them are cryptographically linked. That means box number 1, box number 2 is cryptographically linked to box 1. That means a secret that is generated out of box 1 is buried inside box 2, and similarly, a secret out of box 2 is buried into 3. So they're all cryptographically linked. So that is also computationally very difficult to do. That's what makes it immutable. Coming to the database itself, right? So blockchain databases are no different. They all use NoSQL databases because it is schemaless. The way blockchain writes into these databases is a different schema, and that's what makes it different. It's not the database, it's the way blockchain records data inside these databases.
How mature is blockchain? Is it widely accepted now?
So we've been working with blockchain since 2016, but the technology itself is as old as 2008, right? So 2008 is when Bitcoin came into existence, and 2014 is when Ethereum came. And right around that time came the Hyperledger project. A number of thought leaders, I would say, or even enterprise companies like IBM saw the value of blockchain. They saw that the technology can be applied to solve a variety of problems. So back in 2016, the Hyperledger Consortium was formed. The Hyperledger project focuses on enterprise applications that are based on consortium or private blockchain networks. Now, private blockchain networks typically are membership based. It is not like open for everyone to come in, open an account. So it'll be, for example, Trust Your Supplier from TYS is a membership based private blockchain network. Members join this network, they are given cryptographic credentials, and then they do business. And blockchain being a team sport, all the members have some common interest, and therefore they are able to interoperate, cooperate, and collaborate on top of the blockchain. So enterprise blockchain actually helped to bring about a lot of applications dealing with supply chain, finance, you can say even healthcare. The technology is also maturing, and people's understanding of how to use blockchain is also maturing, and so they are able to make more informed decisions.
Are there any current use cases that you can kind of speak to where blockchain has been applied?
That is a good question. So we ourselves have been in Chainyard, have been involved with a number of projects, right? And each project has been pretty unique. Some of them have been recognized. Trust Your Supplier is an excellent implementation of a blockchain solution from concept, in fact, from ideation or concept all the way to production. So we had an idea and we used all our learnings in order to see how to build it. In fact, Trust Your Supplier went through many iterations. So the first one was a concept, then it became a POC, then from POC, MVP was built, and then finally, after a lot of learnings, it is now in production. So building a blockchain solution definitely takes a lot more than just how to code it and develop it, right? It involves how do you govern the blockchain network? How do you build it in production? How do you keep the costs low? What kind of network infrastructure you require? So that's a very good example of something that was taken all the way to production. There are many others like TradeLens from IBM, Food Trust, Walmart Food Trust, again in partnership with IBM is good. Even in the public space, there are some good blockchain technologies like Chronicled, which deals with cold chain. There is MediLedger. So there are blockchain projects that have really done very well. In fact, Ethereum is nurturing a number of good projects, and we have built some good projects on Ethereum. I think some of them are in POC and some of them are cross POC levels. One good example would be how do you tokenize grants, right? The federal government gives a lot of grants for certain projects, and these grants in the past were just money issued and could not be tracked. So now with using Ethereum, the project was able to tokenize these grants and then use tokens as payments to the different service providers, as well as verify that the actual service was performed according to satisfaction. So that's a pretty interesting way by which the government is using blockchain technology.
Okay, yeah. I didn't even think about it being traceable as something important and used in that way when you just mentioned the college grants.
See, there are specific use cases in which blockchain works. So anytime it is a team sport, so you do have to have at least more than one party that is interested in that common business problem. So blockchain fails if it is just one enterprise that is trying to build it for its own purpose. So it is a team sport, so you need to have at least more than one organization as part of the consortium or common business interest. Now, there are very specific use cases that blockchain solves, like traceability. Track and trace is a very common problem that blockchain solves. I want to know the provenance of my product, all the ingredients that went into the manufacture of this product or the parts that went into the manufacture of this product. The other one is smart contracts, like code is law is a common statement in the blockchain world, especially in the Ethereum world. So purchase orders and purchase orders, invoices, these are all business contracts. Blockchain is very good in codifying this and having a common view of how these contracts execute for all the parties involved in that particular transaction. There are other specific use cases like regulatory use cases. The government wants to track sustainability, like how are different enterprises complying with certain regulations. So can they put all the regulatory reports on the blockchain and securely share it with the government? That is a pretty good use case. Then healthcare records, healthcare records are all over the place. How can the blockchain help to secure healthcare records and allow secure sharing of those records with all the parties like clinics, hospitals, doctors, pharmacies? How can it enable? So there are many different use cases. And so identifying the right use case for the blockchain is very important if a project has to be successful.
You mentioned that blockchain started all the way back in 2008, I believe.
Right.
And to me, that doesn't seem that long ago. And it seems like the technology has moved really, really quickly. What is your vision of blockchain in 2030?
So I've been attending a number of conferences, and in 2030, people won't talk about blockchain. It's just like today's Ethereum, today's database world, right? So we never talk about SAP having an Oracle database behind the scene, right? So today, blockchain is a novelty, and everyone is talking about it. But in the future, blockchain is just part of a solution. I mean, like I'm using a blockchain database underneath my solution. So people will not even talk about it. That is one possibility. But by 2030, that could be a lot of other things that happen. There are so many different networks. So we do see within Chainyard, and I do see that as well, is that some networks may disappear, some may merge with other networks. Then there might be interoperability between different networks, like a trade finance network may interoperate with another supply chain network like Trust Your Supplier. So those are all possibilities. The other thing that we see is that blockchain alone, I mean, a blockchain started because of trust, transparency, privacy, smart contracts, and consensus. I mean, and that were some of the core characteristics of blockchains that triggered a number of applications. But if you see the outside world, IoT, which is the Internet of Things, and AI/ML are also taking roots, and they are solving different kinds of problems. So there would be a convergence by 2030 of these technologies coming together to solve problems differently. For example, if you take IoT sensors, they are transmitting data at an immense rate. That data somebody has to trust. So the blockchain can provide that trust element that the IoT data that came in is accurate and that it has not been tampered with. Now you take AI/ML algorithms, who understands? Some of them are very complex. And those algorithms are processing this data that is coming and giving us insights. Now, do we trust those insights? Did the algorithm actually execute it or somebody bungled it in, right? So the blockchain once again provides that level of trust by saying that this data was used for this calculation and this was the instance of that algorithm. So by 2030, there could be convergence of these technologies coming closer together. And so solutions will become, since the solutions are getting more complex, people want more transparency and trust. So blockchain, AI/ML, and IoT could all come together for newer solutions.
So it'll be more standard. We won't even really think about it, kind of like we don't think about smartphones anymore. We just
Right.
have them, right?
We
It's
just
not a
have
novelty.
Absolutely. I want to clarify one point for you. Now, the problem with Bitcoin is that it is not what do you call environmentally friendly. You burn a lot of energy and you burn a lot of electricity and computational power, which actually many of the folks who are very concerned about sustainability and environmental friendliness, they really think that Bitcoin is not ecologically friendly, environmentally friendly, or even socially friendly, ESG, right? On the other hand, the technology that we use in TYS is more based on leader-based protocols where the finality is immediate and you don't have to do mathematical computations in order to create a block. So that makes us much more environmentally friendly and sustainable.
In your example with Trust Your Supplier, it can also actually work the opposite way where it's more environmentally friendly because you're reducing the amount of either paperwork or other types of transactions.
Absolutely. No, we usually don't use that in the calculation, but yes, from pure blockchain perspective, its energy consumption is very low. All the computers that we run inside the IBM cloud, those are very efficient and they do not burn a lot of energy because the processes, the transactions are very simple and the consensus process is also very simple. And of course, we are a lot more environmentally sustainable because we reduce paperwork and so many other things in TYS.
For those of us like myself, new to blockchain and digital transformation, do you have any advice or tips you'd be willing to share? It's something practical that we can try at work or at home.
Obviously, how can you become familiar? There are many, many resources, but I would say YouTube has got a lot of good videos. If you Google, I mean, just to get your basic information. But if I were to get my get a little more information, I would always start with the public blockchain because private blockchains, you got to program and all those things, right? Whereas public blockchains offer a lot more, what do you call, diversity of tools and technologies and features that you can easily get your hands dirty. Go to bitcoin.org or you can go to ethereum.org and they have a lot of tutorials. If you really learn, they have very simple tutorials and some of them carry videos. That is a very good resource. but also say, just out of curiosity, just open an Ethereum account. Open an account with Coinbase, which is an exchange, and then play with very limited amount of USD if you want to buy a few cryptocurrencies that are not too expensive, and see how it works. You open up a wallet like a MetaMask for yourself. You open an account with install MetaMask and open an account. You have a wallet. You connect that wallet to the Ethereum network. You buy a little bit of crypto and you see how this whole thing works. There are good videos on how to do this very easily. That would be another approach. And then the most exciting thing I found is on Ethereum, there's an application called CryptoKitties. CryptoKitties is nothing but digital cats, and it's considered an NFT. And people actually trade these cats. There's a learning section in CryptoKitties, and you can actually go and use the learn option to see how NFTs really work, and they give you a fantastic explanation.
How cute. And that is really at my level too. That's the level I need to learn more about this stuff. So
CryptoKitties will really keep you fascinated because the world of NFTs, which we never talked about, non-fungible tokens, is getting a lot of traction on blockchain. You saw, Jack Dorsey, his first tweet became an NFT, right? And it traded for $1 million or more. Similarly, there are many other NFTs that is catching on, and they are being traded on public blockchain networks.
And I will post some of these links in the show notes as well so that our listeners can find them.
Absolutely.
Yes. So Mohan, what projects do you have on the horizon and where can our audience find you to follow and connect?
So we are doing some interesting projects now. And so right now what we are doing is the tokenization of real estate, right? We're working with a company that wants to tokenize real estate assets and then offer those tokens to public investors. This is a way by which you can, the company can raise funds to purchase properties. And for those tokens that these investors purchase, they get dividends, dividends which is actually coming through rents and other means of income generation. So we are tokenizing it, meaning like we are building it on a public blockchain like Binance, and we are tokenizing the assets. We are also working with wallets and how to move money between wallets, how to generate tokens. So that's very interesting. The second one that we have worked on in the past, but there seems to be a lot of interest is the wallet. It's a digital wallet that runs on a mobile phone, and the health records are under the control of the individual who owns that phone and who owns that wallet. So we built that, but now we see that there's a lot more requests on, in general, how to share healthcare records between the patient and healthcare organizations. And so we are looking at the wallet. There are companies that have asked us to help them with giving consent for sharing the records. So we have, since we have done a lot of work in this space, we are looking at how to use our mobile wallet for that purpose, or even do some other algorithms to satisfy those kind of business requirements. We're also working with a university trying to build an NFT. How does NFTs operate, right? For non-fungible tokens. There are people who want to just trade. I mean, there was a kid who actually drew dinosaurs and was doing NFT trading on the blockchain. Now, so there's a lot of interest in NFTs, and we are building a sample example of an NFT trading application that students can use. So those are a couple of interesting things that we are doing. People can always email me or connect with me on LinkedIn. I'm on LinkedIn under Movee97. I can put that somewhere, MOVEE97. Easy to find me.
Mohan, thank you so much for schooling me on blockchain basics.
Yes, it was completely ABCD for me back in 2015. I think it took me a while, but I think things have been simplified since then, because people started understanding the technology, and there's a lot of material and content available, and many of them have tried to simplify it for various audiences. So things are much better today than what it was back in 2014, 15.
I really appreciate it.
Thank you so much.
All right. Take care.
That's it for this episode of Procurement Block. I'd like to thank my guest Mohan Venkataraman for joining me on the show. If you want to play around with blockchain, links to the resources Mohan recommended will be in the show notes at procurementblock.com. Let us know if you give any of them a try.
Procurement Block is produced by Trust Your Supplier. You can reach us at procurementblock.com. Show notes are available on our website, and you can leave your questions and comments via the listener comment form. Thank you for learning with me today. I'll leave you with wise words from Benjamin Franklin. An investment in knowledge pays the best interest.